Okay, here we are at lesson 21. Only one more lesson to go before we end our unit on ratio and proportion. And we're doing an exercise in changing scales. So what you're going to need in order to complete this lesson is you need your scale drawing of the dream classroom you did for lesson 20. At least the measurements for that. And then for lesson 21, you need the worksheet, and you'll need a ruler with centimeter marks and a calculator. All right, so let's take a look at exercise 1. You're going to read the problem and create a small scale drawing based on the factor given in the grid provided. So we're going to be doing another scale drawing of our dream classroom that needs to be 1/4 of the current size. All right, so let's talk about this before we do it. First of all, would the new scale create a larger or smaller drawing as compared to the original drawing? So if the scale is 1/4 of it, then that means that it would be smaller because 1/4 is smaller than 1. So how would you use the scale factor between scale drawing 1, which we're going to call SD1, to scale drawing 2, that's the new drawing you're going to be doing. We're going to call that SD2, to calculate the new scale drawing lengths without having to get the actual measurements first. So how can we just go ahead and calculate this? Well, we're going to take the original scale drawing lengths, so that's why you need your worksheet from lesson 20, and we're going to multiply those lengths by 1/4 to get the new scale length. So what we're going to do is we're going to finish creating our scale drawing 2 based on the dream classroom drawing. So let's go ahead and switch over to here. So I've already kind of pre-done some writing, so you don't have to wait for me to write. But let's go ahead and, if you want to pause the video and copy this stuff down, you can. But I've already wrote down that our scale drawing from scale drawing 2 to 1 is going to be 1/4. So SD1, the original length, was 6 2/5 inches. And so we want to figure out what is the new one. So again, if we have y is equal to 1/4 x, then we want y to be 1/4 of 6 2/5. And getting our calculator out, we're going to do 1/4 times 6 2/5. And simplifying this gets us to 1 3/5. If you can see that there, 1 3/5. All right, so if it's 1 3/5, we know that our new drawing length is going to be 1 3/5 inches. Again, we don't have our ruler divided into fifths, so we're going to say it's going to be approximately 1 9/15. Okay, so 1 9/15 inches, which is close to 1/16. All right, so now let's do the width. If the width is 6 inches, then the new one would be y equals 1/4 x. So we are going to take 1/4 of 6. And we don't need our calculator for this because we know it's going to be 6/4. And 6/4 is 3/2 or 1 1/2. So it's going to be 1 1/2 inches for the other side. All right, so let's do those two first and then we'll get to the door width. So now that we know our inches, and I'm going to go ahead and do this in a darker pen so that it shows up. As long as you just kind of center this in the grid, it doesn't matter how you do this, but you need to find a starting point where 0 lines up And again, we said our first one was 1 9/15. So I'm going to go over 1, and then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So approximately about there. Now it still doesn't really, so let's just do that. Okay, so there is 1, oops, we'll mark this 1 3/5. All right, so there's our 1 3/5, and now we're going to turn the paper, and we're going to do the width, which was 1 1/2. Okay, so there is 1 1/2. And you can go ahead and finish the rest of the drawing and continue the video. All right, so now you should have your room that looks similar to this, and now we just need to mark the width of the door. All right, so if our door width is 5/6, then again, y equals 1/4 x, and we're going to do y is 1/4 times 5/6. And when you get that, it is going to be 5/24. So now, in order to get from 5/24 to, again, that's going to be kind of hard, we want to get to 1/16 of an inch. It's what number times 24 is going to get me to 16? Well, that's going to be 16/24. Or if you reduce it down, it's going to be 2/3. Okay, so we're going to take 2/3 and multiply 5 by 2/3, and that's going to give me 10/3. So 10/3, which is the same as 3 1/3. So we want 3 1/3 16ths. So now turning our paper, we're going to go ahead and measure 3 1/3. Well, at least 3. So 1, 2, 3 means that our door is about right here. So that is 3/16, a little bit more than that, and of course it opens up, and that is our door. Okay, so we have everything labeled for our new scale drawing, which is 1/4 of our original scale drawing. Okay, all right, so let's go ahead and flip back over. So now we're going to prove to the architect that our scale drawing 2 is actually a scale drawing of the original room. So how can we go about proving that the new scale drawing is actually part of the original room? Well, we take the scale lengths of scale drawing 2. They need to be proportional to the actual lengths. So we need to find the constant of proportionality, or the scale factor. So how do we find the new scale factor? Well, we're going to divide one of the new scale lengths by its corresponding actual length. And what if we know, or what if the actual length is not known? What if we didn't know that it was 32 by 30 feet? How could we figure that out? Well, we could calculate the actual length by using a scale factor on the original drawing, divide the scale length, or dividing the scale length of the original drawing by the original scale factor. So what does that look like? Let's go ahead, and you're probably going to need to do this in your math journal. So I've kind of got this set up. How can we figure this out? We have the actual room to our scale drawing 2. So if our actual room is going to be 30 feet, and we want to know what is the scale factor if the width was 1 1/2 inches. Well, again, the first thing we have to do is we can't find a scale factor from feet to inches, so we have to convert feet to inches. So that would be 30 times 12 is equal to 360. So we know that's 360 inches. Now we have it from inches to inches, so we're going to use our y equals kx. Remember, we're looking for k right now, but y is going to be the inches, so y is representing our SD2 width, and x is representing our actual. So that means that we would have 1 1/2 is equal to k times 360. And what happens when we do that is now we have 1 1/2 divided by 360. So let's go ahead and see what that is. You can grab your calculator. All right, so I need 1 1/2 divided by 360. That gives me 3 over 7/20, which I can simplify, and I get 1 over 240. So our scale factor is 1 over 240. And we're going to put that up here. 1 240th. All right, so that answers that first question. The second one, what if we knew our scale drawing number 1, the width was 6 inches, and we knew that it was a scale factor of 100 or 1 over 60. Again, x is going to be our actual, in this case, our actual width, and y is going to represent our scale drawing 1. So we're going to use again y equals kx. That means that y is 6, and we know that the scale factor is 60, and it's times x. So how do I find x? Well, if it's 1/60th times x, and I need to know that, then I'm going to end up dividing. So this is going to be 6 divided by 1/60th. So let's go ahead and do that on our calculator. Go ahead and clear it. So if I have 6 divided by 1/60th, I get 360. And if that sounds familiar, that's 360 inches, which is the same as 360 inches is equal to 30 feet, which is our width. All right, so width of the actual room. All right, so that is how we figured those two things out. Let's go ahead and switch back over and take a look at our first exercise. So we're going to create a new drawing of a trapezoid using a scale factor of 1/3. So you want to turn your paper over, and you'll see a picture of a trapezoid. This is where you're going to need your centimeter ruler. So let's go ahead and show how we're going to do this using 1/3. All right, so if you notice, we have a centimeter ruler showing that it is 7 centimeters for the base of our trapezoid. So if we have a scale factor of 1/3, which I have written up here, then basically all I need to do is I need to multiply 7 by 1/3, because remember I'm making a smaller, and I've already pre-drawn it here, but I'm making a smaller trapezoid. So 7 times 1/3 is 7/3, and that is equal to 2 1/3 centimeters. So I know that if this is 7 centimeters, this is going to be 2 1/3 centimeters. And if you don't believe me, then when I measure this, it is 2 and about 1/3 of the next centimeter. All right, so then the next one we need to measure. Go ahead and measure it. We'll go to the right side first, and that is about 5.5 centimeters. So if this is 5.5 centimeters, then we're going to take 5.5 times 1/3, and using our calculator, 5 1/2 times 1/3 gives us 1 5/6. So this would be 1 5/6 centimeters. So that's over here, 1 5/6. So almost 2 centimeters, not quite. And then continue to measure the rest of the lengths. This is, we'll call this 3 centimeters, since it's close enough to be 3. So 3 times 1/3 is 3/3, which is equal to 1 centimeter. So this should be 1 centimeter right here. And the last one is 5 centimeters. So that is 5 times 1/3 is 5/3, which is 1 2/3 centimeters. All right, so that is how you find the measurements of a new, and then if you didn't have this already drawn, you would draw this measuring 2 1/3. Now it might be a little tricky to get these completely perfect, so if it doesn't measure out exactly, don't worry about it. It's the labeling that counts the most. So just have the correct labels on that. All right. So how do we find a new scale factor? Let's say we want to do another one. We're going to divide one of the new scale lengths by the corresponding actual length. So if I wanted to go backwards, I would take 1 centimeter and divide it by 3 centimeters, and 1 divided by 3 is 1/3, and that would give me my scale factor. What if the actual measurement wasn't known? How could we find it? Again, if I knew that I had 1 centimeter and I had a scale factor of 1/3, I would take 1 divided by 1/3, and it would give me 3, which is, again, the top of the trapezoid. That would be 3 centimeters. All right, so let's go ahead and demonstrate that again, and we'll do this on the same paper. So if I didn't know what the scale factor was, I could take, we'll take the easy one, we could take 1 centimeter is to 3 centimeters. So what I would do is 1 divided by 3, which means 1/3 is the scale factor. All right, now let's say that I didn't know the original, but I knew the length of the scale drawing, and I know that it's 1/3. Well, if I had 1 centimeter, and I know that the scale factor is 1/3, then I would take 1 and I would divide it by 1/3, which is the same as 1 times 3 over 1. And that gives me 3, and therefore 3 centimeters is the actual length. So that's how you'd figure out, you can use that to find missing pieces of information. All right. So what I'd like you to do is to complete A through C on the other side or on the next page. That has to do with more questions about the trapezoid, and then it's going to ask you to draw a larger base of 10 centimeters. See if you can figure out the scale factor with that. When you are done, continue the video. All right, so let's take a look at A through C, and here are the answers to that. So the scale factor, we already figured that out, was 1/3, but then if you compared the base of a new trapezoid at 10 centimeters, what is the scale factor between the original and the actual? Well, if it was 7 centimeters on the drawing and then it went to 10, it would be 7/10. And then what is the scale drawing between the new drawing you made, which was 1/3, and the actual trapezoid? Remember, with a base of 10, and so you take 2 1/3, which was 7/3, and when you divide that by 10, that becomes 7/30. So that is how you find the scale drawing, or the scale factor between the actual base of the trapezoid, which was 10 centimeters, and your new drawing, which was 2 1/3. So it's 7/30 of the original. All right, so on a separate sheet of paper, you're going to create a new scale drawing for the trapezoid using SD1, or scale drawing 1, so the new scale drawing that you have, and you're going to increase that or enlarge that with a factor of 4, and then calculate the scale factor between your drawing and the original trapezoid on the lesson worksheet. So the one with 7 on it. So go ahead and pause the video, try that, and then we'll compare your answers. All right, so let's see what you came up with. Let's go ahead and show the answer. And this is what you should have. You didn't actually have to draw it out, but if you take the original drawing that we did, SD1, which is right here, we can go ahead and mark this. This is SD number 1. All right, and we're going to apply a scale factor of 4 so that it's going to look like this right here. Then we take all our measurements, 1 centimeter, 1 5/6, 1 2/3, and 2 1/3, and we're going to multiply it by 4 because we are making an enlargement. So that means that my lengths now are 4 centimeters, 7 1/3 centimeters, 6 2/3 centimeters, 9 1/3 centimeters. So this is our new drawing, SD2, based on a scale factor of 4 from the SD1, not the original. But then the second part of the question asked, what is the scale factor from SD2, which is right here, to the original, which was up here? And if you, again, just sticking with the base, you can try this with any of the sides, but if this was 9 1/3 centimeters, and up here is 7 centimeters, then I divide, which I turn 9 1/3 into 28/3, divided by 7, gives me a factor, a scale factor of 4 to 3, or 1 1/3.